So section 10.1 is systems of linear equations. A system of equations is just a set of equations. A solution to a system of equations is a point that lies on the graphs of all of the equations of the system. That is to say, in the intersection of all graphs of the equations in the system. So systems of two linear equations with two variables are probably the simplest type of systems of equations that we'll have. There's three possibilities. You can have a single solution, which is what happens when you have two non-parallel lines. They intersect in a single point. You can have no solution, which is when you have two parallel lines that are not the same line. And you can have this third situation where both equations have the same graph, in which there's infinitely many solutions. Specifically, all the points on the line are solutions. So you can see it's kind of orange. I made an orange and yellow and kind of put them together, but really you can only see the orange there, but that's actually two lines, one lying on top of the other. So when there's one solution, we say the system's consistent. Actually, if there's one or more solutions, we say it's consistent. So that's the first case and the third case, consistent. Inconsistent means there's no solution. Okay, so they will ask you, is this system consistent or inconsistent? And you would say inconsistent if there's no solution, consistent if there's one or more solutions. Okay, independent, when you have one solution, that's independent. When you have two parallel lines with no solution, that's independent. And when you have two lines that are the same, that's dependent. Dependent really has to do with, technically it has to do with one of the equations in the system being a linear combination of the other equations in the system. That's the technical definition. But for us, independent is just going to mean either you get no solution or one solution, and dependent would be more than one solution. Okay? So consistent has solutions, and inconsistent, no solutions. Dependent, more than one solution, and independent, 0 or 1 solution. If you take a linear algebra class, they'll define that more precisely, as I just did, as if one of the equations is a linear combination of the other equations, then it's dependent. But for us, this is good enough. More than one solution, they're dependent. Independent if it's 0 solutions or 1 solution.